Okay, so we are going to build the unit circle. We know that the unit circle is a circle of radius 1, which this is what we're going to define the circle to be, a radius 1, centered at 0, 0, so we're going to draw a circle, and then we're going to try to find some points that we need to learn about. So first thing, I'm going to move this to 0, 0, center it about as good as I can, draw my circle. We now have the unit circle. We could, if we wanted to, since this is a radius of 1, we see that there's 5 blocks for the radius, so that means each block's about 0.2 units. That doesn't really matter, but if you need some context, that's what we're dealing with. Our first thing we're going to do is label all of the points that would lie along the x and y axis. So those would be at 3 o'clock, at 12 o'clock, at 9 o'clock, and at 6 o'clock. And we would know that those coordinates is 1 in the x and 0 in the y. This point up here would be 0 in the x and 1 in the y. This point over here would be negative 1 in the x and 0 in the y. And this point down here would be 0 in the x and negative 1 in the y. So those points should be pretty obvious and pretty easy to label. So now we're going to find some other points. We are going to draw an equilateral triangle, and some of you might remember how to do that from geometry last year. So I'm going to take this circle and I am going to center it on this point over here. And you can see that now the outer edge is in the middle and the point centered on that point. I am then going to find the intersections of it. There's one down there, and there's another intersection right up there. So those are my 2 intersections. Let me get rid of or move this compass for a moment. So we are going to look at these 2 points. What I want you guys to see is that we know the distance from this point to this point is 1. And because we used a circle to find this point up here, we know that both of those distances are 1, right? This one from the previous radius and the other one from the circle we just drew. So that means that this is an equilateral triangle, and if we wanted to then drop a vertical straight down here, we would know that each length here is 1/2 each. And based on that, and the fact that we know the equation of a unit circle, which is x squared plus y squared equals 1, actually, we'll just do that over here. We know the equation of a unit circle is that we can now try to find the y coordinate of this thing, of this point. So we know the x coordinate is 1/2. The question is, what is the y coordinate? Well, we can just plug in 1/2 into this equation. When we square 1/2, we get 1/4. We're going to subtract 1/4 from both sides and get 3/4. So y squared equals 1 minus 1/4 is 3/4. We want to find the square root of that in order to get y by itself. So we take the square root of both sides, and we remember the plus or minus. And then when we take the square root of a fraction, it's the square root in the numerator divided by the square root of the denominator. So we end up getting y is plus or minus the square root of 3/2. Well, we can infer, because the point we're looking at exists above the x-axis, that it's the positive one. So we know now that this is √3/2. So we have that point. We could do the same argument and the same math if we wanted to find the coordinates of this point down here. But we don't necessarily need to go through it all, because we know through symmetry that the x coordinate is still 1/2, because this line, we could draw it all the way down. And then the y coordinate, through symmetry, instead of the positive version of it, we're going to get the negative version of it, so negative √3/2. So now we have that information. I'm going to attempt to erase some of this stuff. as neatly as I can, just to get it out of the way. Pretty good. We don't need these equations anymore. We certainly don't need this one. We didn't even use it. I'm going to leave that other one up there. So our job now is to find some more points, and there's a lot of symmetric points here. We could eyeball it and look right across here and find this point. We could eyeball it and find that point, but instead we've got our compass, so we'll just put it right there, and then I will lock it, and I will, where did my thing go? Rotate it right to there, boom. There's another point. And there's my last point. So now we've got all those points, and I'm going to find a few more. So I'm going to, well, similarly put my circle right here and find all of my, whoops, I hit undo there. We will find these other intersections. So we want that one, and we want that one, and we are going to go this, put this one up here, and we will find, I don't know what happened to my thing. Oh no, oh no. Pardon me. Trying to use new technology for myself here. So here we have another point right here that we can draw. And similarly, we have this intersection over here. So let's move this piece out of the way. There we go. So now we have all these points that we need to find. And then we're going to clean this up a little bit, but they are just the intersections that are symmetric with the initial ones that we did. So let's make some quick assumptions here. First of all, we should be able to figure out this point right here, because if it's 1/2 unit to the right, then it's going to be 1/2 unit to the left, which means it's -1/2. The y values of these 2 points is the same, so we're going to call it -√3/2. That one's easy, and we will come up here and do this point right there. And if it's 1/2 unit to the right, so it's 1/2 unit to the left, -1/2. Notice vertically these 2 points here are lined up, and we have also it's above the y-axis, so it's √3/2. Notice they line up horizontally, so those points should be pretty easy. I'm not going to go through the math. I will change colors. These points here also make an equilateral triangle, and if we dropped our perpendicular, you would know that the top and the bottom of that are both 1/2. So we can find the coordinates of each one of those points pretty easily, and we will do that using green. So we know now that the y coordinate is 1/2, and we can infer, because it still solves the same equation up here, that the x coordinate must be √3/2. And similarly down here, we realize that we're below the y-axis, so we have -1/2 for my y, and my x is going to be still positive √3/2. Whoops, 2, that's a 2, right? And you can see that these 2 points are lined up vertically. So we should be able to come over to here and do something very similar. We know it's going to have the same y value, so it's going to have a y value of -1/2. And the x value is going to be -√3/2, because it's left of the y-axis. Then we come up here, we look at this point, and we say, hey, it's got the same x value. So the x value is -√3/2, and it's got the same y value as this one over here, so it's got a y value of 1/2. So there we have all of those points labeled out. Very good. We've got one more set of points that we are going to do, and they are the 45 degree line. So we can look at this line here, and if we were to draw a vertical down here for 45 degrees, what we would notice is that each leg is equal, right? Each leg is equal. So we don't know what the values are. I'm going to use a different color here. We don't know what these values are yet, but we do know that the x equals the y. So we're going to come back over here to our equation. I'm going to move this thing out of the way. We'll come back over here to our equation that we used before. And we know that the x equals the y, so we have x squared plus y squared equals 1. And because x equals y, we'll just change this to x squared plus x squared equals 1 just by basic substitution. Now we're going to solve this. X squared plus x squared is 2x squared equals 1. Divide both sides by 2, we get x squared is 1/2. To get rid of the square root, we take the square root of both sides. We remember our plus and minus sign because this thing is very symmetric, and we get x is plus or minus root 1/2, but we are going to call it root 2/2, plus or minus. All I did was rationalize that fraction. If you have questions about that, let me know. So now we know that this is root 2/2, root 2/2, and it is symmetric. We can find the same point over here that's symmetric. It's got the same y value, so we know that the x value is going to be negative root 2/2 and root 2/2, the y value. And then we can find the same value in between here, and this value would be negative root 2/2, because notice it's lined up vertically with that, and negative root 2/2 because it's below the y-axis. And then we can come over here and do the last one and say that this one is, the x is positive, root 2/2, and the y is negative, root 2/2. And those are the coordinates of all the points that we care about. We're going to go back through in a moment and figure out the radian values for each one of these points.